All right, so if you're a software engineer, you have definitely felt that dread from the system design interview. It can be one of the most intimidating hurdles out there. But what if I told you there's a clear, step-by-step way to totally nail it? Well, today, we're breaking down exactly that.
So picture this. You walk into the interview, you sit down, and they hit you with this question. It's so broad, it's kind of vague, and the clock is ticking. The pressure is on. It honestly feels like they're asking you to build an entire city from scratch in under an hour. But here's the secret.
The interviewer isn't actually looking for some flawless, production-ready architecture. Nope, what they really want to see is how you think. How do you deal with ambiguity? Do you ask smart, clarifying questions? Can you talk about trade-offs? It's all about collaboration. Seriously, the journey you take to get to the design is way more important than the final destination.
And to help guide us on that journey, we're going to use this simple but incredibly powerful 4-step framework. This structure is going to help you navigate the entire interview, making sure you hit all the key points your interviewer is looking for.
Okay, let's actually put this framework to the test and start designing our system. Now for step 2, proposing that high-level design, you never, ever want to start with something super complex. The best approach? Begin with the absolute simplest thing that could possibly work.
And, well, here it is. Everything. The application, the database, the whole shebang, just running on one single server. This is your starting point, your initial blueprint. It's simple, it's easy to understand, and it's the perfect foundation to build on. From here, we're going to evolve this design, piece by piece.
And here comes our first big problem, right? Scale. As more and more users start flooding in, that one little server is going to get completely overwhelmed. The web app and the database will be fighting for the same CPU, the same memory, the whole system will grind to a halt, and eventually it's going to fail.
So, the very first, most logical move, we decouple. By splitting our architecture into a web tier and a data tier, we can now scale each one all on its own. If we need more horsepower for the app, we can add it without touching the database, and the other way around. This is like a fundamental principle of designing distributed systems.
Okay, so how do we actually scale these new tiers? We've basically got two options. There's vertical scaling, or scaling up, which is kind of like buying a bigger, more powerful engine for your car. It's simple, but eventually you just can't buy a bigger engine. Then there's horizontal scaling, or scaling out, which is like adding more cars to your fleet. For the huge systems we're talking about today, this is almost always the way to go.
All right, so we've scaled out our web tier. We've added more servers. But this just creates another problem, doesn't it? How do we spread the traffic between them? And maybe, more importantly, what happens if that main server goes down? The whole site goes offline, even though we have a perfectly good backup server just sitting there ready to go.
And the solution here is a load balancer. Seriously, just think of it like a traffic cop for the internet. It sits right in front of all your web servers and it intelligently directs all the incoming requests across the entire fleet. This doesn't just improve performance by spreading the work out, it also gives us redundancy. If one server fails, the load balancer just goes, okay, and stops sending traffic to it. Simple as that.
And this right here, this is a key interview move. By bringing up a load balancer yourself, you're not just solving the immediate problem. You're showing the interviewer that you're thinking ahead. You're thinking about reliability, about availability, about building a system that doesn't just fall over.
Okay, great. So our web tier is resilient. Awesome. But all we've really done is shift the bottleneck, right? Now our single database server is the new single point of failure. If that database goes down, the whole application is going down with it. So we need to apply that same idea of redundancy to our data tier.
And that's where database replication comes into play. A really common way to do this is with a primary replica, or you'll hear it called a master-slave setup. The main, or primary database handles all the write operations, so all the inserts, updates, and deletes. Then all that data gets copied or replicated over to one or more replica databases. And those replicas? They're dedicated to just handling read requests.
And the benefits you get from this, they are huge. Performance gets a major boost because you're splitting up the read and write traffic. It's way more reliable because your data now lives in multiple places. And most importantly, it gives you high availability. If a replica database dies, we've got others to pick up the slack. If the primary fails, one of the replicas can get promoted to be the new primary, which keeps downtime to a minimum.
Now, this whole setup is what allows for that amazing horizontal scaling. But there's a catch.
It only works if our web tier is what we call stateless. All that means is that no single server holds on to a user's specific information, like their session data. Instead, that state is stored in a shared place, like a database or a cache. This is what lets any web server handle a request from any user at any time, and that is the absolute key to scaling smoothly.
All right, so far we've been all about scalability and reliability. That's great, but let's be real. Users care about one thing above all else: speed. Every time a page loads, we're probably making a bunch of calls to our database, and that's almost always the slowest part of any system. To make things faster, we have to reduce that database load.
So how do we do that? With a cache. A cache is just a super fast in-memory data store. When a request for data comes in, the first thing we do is check the cache. If the data's there, boom, we return it instantly without ever having to bother the slow database. This makes a massive difference in response times for stuff that gets requested all the time.
You know, in an interview, just saying, let's add a cache is fine. It's a good answer. But what really separates a great candidate is talking about the trade-offs. How long should data live in the cache before you say it's stale? How do you make sure the cache and the database don't get out of sync? What do you do when the cache is full? What do you kick out? Talking about these points shows a much deeper level of understanding.
And for another massive performance boost, we can offload all our static stuff, images, videos, CSS files, to a content delivery network, or CDN. A CDN is basically a global network of servers that caches this content physically close to your users. So a user in London gets the website's images from a server in Europe, not from one all the way over in California. And the result? Much faster load times for everyone. And there you go. Look at that. We've systematically taken our simple single-server setup and evolved it step by step into this robust architecture that can handle a ton of traffic. So now, let's move to that final, crucial step of the framework, the wrap-up. Okay, so in those last few minutes of the interview, you really want to stick the landing. This is your chance to look back on the design you just created. You want to be the first one to point out its weaknesses and suggest ways to improve it. Showing that you know no design is perfect, that's the sign of a mature engineer.
This is your chance to just recap the core principles you used, almost like a summary of your design philosophy. You can mention keeping the web tier stateless for easy scaling, building redundancy at every single layer, using aggressive caching for speed, offloading to a CDN for global reach, and then you can even talk about future needs, like maybe sharding the database or the importance of robust monitoring. It just neatly packages up all the smart decisions you made.
See, the real key here is to finish by looking ahead. Don't just present a design and say, I'm done. Talk about how you would operate it. What metrics would you track? How would you handle logging and alerting? This shows the interviewer that you're not just a designer, you're an operator who thinks about the entire lifecycle of a real-world system.
And that really brings us to the final and maybe most important question. Because system design is never really done. It's a continuous process. You solve one bottleneck, and that just reveals the next one in line. So what would you watch first? CPU load on your web servers? Maybe database query latency? The cache hit rate? Your next challenge is always right around the corner.